Hi, it's Mr. Shrum, and I am going to go through the course activity as a workshop today to explain how to best approach the tasks and give you some examples of exercises or activities that elevate your heart rate or fatigue your muscles. So here we go. So we're going to investigate uh, how to explain how exercise affects our heart rate and our muscular activity. During exercise, your body lets you know how hard you're working. Your muscles contract, your breathing increases, heart rate changes. And in this specific activity, we're going to observe the changes in your pulse and muscles during physical activity, and then relate your results to your body's internal mechanisms that maintain homeostasis. Your body's always wanting to keep things relatively stable. So if you get too hot, you start sweating. If you get too cold, you want to heat your body up, or your body tries to heat itself up by restricting blood flow to certain areas and things of that sort. So here's our rubric for task 1 and task 2. Task 1 is about measuring pulse. So we're going to come up with a hypothesis, collect some data, choose 2 activities, and then input the readings, calculations, make a prediction, record your data, and then you want to analyze the things after you do the um, data collection phase. And you'll repeat the same thing for task 2, and then task 3 is something a little different. So I'll explain to you after we do task 1, which is measuring pulse. So we need some type of stopwatch or application that can track time. So you can use your computer, your smartphone, tablet, watch if you have one of those, paper, pen, or pencil, or you could just type things onto the computer as well. Part A is finding your pulse, either on your neck or on the carotid artery near your neck, and then also the underside of your wrist. Like these pictures show, don't press against the skin. You want to just lightly touch it and then feel the gentle pulses of your heart. And we're going to measure the pulse during 3 different activities. So, first, you want to measure your pulse at rest, and then while doing 2 activities of your choice. So, a moderately intense activity like walking, and then picking something more strenuous or intense like jogging, aerobics, or jumping jacks, push ups, something like that can get your pulse up. Jump rope if you want. And choose activities that you can sustain for 10 minutes or so. And maybe you're not running the entire time, let's say, but for 10 minutes you're alternate you're mostly doing a rigorous activity. So these activities can be performed indoors or outdoors depending on your space. If you have limited space, you can perform the activities in place. So you could like run in place, jog in place, jumping jacks, burpees. That's a fun exercise too. So here, for example, they chose walking and jogging. Now you want to collect the data. So it says we have 3 trials, beats counted in 10 seconds, and then beats per minute. So first, sit as still as possible for 10 minutes and then measure your pulse for 10 seconds. Repeat this test 2 more times. And for each trial, multiply the measure by 6 to find the number of beats per minute. 10 seconds, measure your pulse for 10 seconds, multiply that number by 6, and that gives you the beats per minute. So you're not sitting there counting for an entire minute, just saving you some time. And then take the average of the 3 values. So let's say oh, I got 10 beats per second, so I had 10 seconds, 10 beats in 10 seconds, multiply that by 6, 60 beats per minute. So you have 60, 61, 59, something like that. Then you would add those up, and then you would divide by 3. So 61 plus 60 plus 59, add it all up, divide by 3, and you get an average of 60 beats per minute. So here it shows you they got 10 in 10 seconds, 11 in 10 seconds, and then 10 in 10 seconds again. So we have beats per minute, 60, 66, 60, and those average out to 62 beats per minute. How much do you think your pulse will increase during the two activities? So this is the prediction part. I think my pulse will show a uh, a slight increase while I'm walking, and this person thought maybe in the 70s, 70 to 75 beats per minute. That's elevated, but not uh, very high, where your body's very strained. You will be able to complete a conversation, hold a conversation while you're walking. However, if you're jogging, maybe your heart's getting up there towards 100 beats per minute, and having a conversation and breathing is going to be a little more difficult, right? So now we're going to do a 10-minute activity. So pick activity 1, which is walking for the example. Activity 2 is jogging. And so for activity 1, you're going to walk for 10 minutes. And then every 2 minutes, you're going to take your pulse and wait for 10 seconds and then write down that number. So 2 minutes, count the beats for 10 seconds. At 4 minutes, you do the same, 6 minutes, 8 minutes, and then lastly 10 minutes. And then you switch to the other activity. You actually want to rest between these activities. You don't want to walk and then immediately start jogging. That's unnecessary. So walk for 10 minutes, rest for 5, and then jog for 10. That might be an easier way to do things. And then you're just measuring your pulse every 2 minutes. How many beats do you get in 10 seconds? Part B is after all that data collection phase, and you want to put those numbers into this graph. And you'll see that in this explanation, you see the pulse, the beats per minute versus time. Walking is the green here, so you see it was pretty elevated. So here's 60, 62 was the average for this person. So it was elevated fairly consistently while he was walking. He or she was walking. And then while they were jogging, it definitely steadily increased and got up to 100 plus beats per minute. Now we want to compare the two activities on the graph. Did your predictions match your results from before? It says, while walking, my pulse reached 78 beats per minute. This person, for example, predicted 70 to 75. While jogging, my pulse increased to 102 beats per minute as predicted. So this person, for example, this person made fairly accurate predictions. And it's okay if you did not, right? Maybe you were expecting your heart rate to be lower or higher. That part's not important. It's the fact that you're measuring your predictions versus the results. Now we're going to talk about the variables, independent, dependent. The independent variable was the amount of activity. So the amount of the activity did not depend on your pulse, right? Your pulse depends on the amount of the activity you are doing. Hopefully you're familiar with that concept. If not, message me about it and I will explain that to you in more detail. And then lastly, we have question 4. Why do you think the change in pulse rate helps your body maintain homeostasis? During rest, muscles are not doing a lot of work, right? They're holding your body together, letting you do certain tasks, but the muscles work harder when you're very active. That means the body needs to pump more oxygen to the muscles to support the physical activity. This process requires the heart to beat at a faster rate. Thus, this increases that pulse rate. And this increase would help your body achieve homeostasis. So it's always trying to maintain stability. That's task 1. I will stop this video and start task 2.